Good afternoon, and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is Laurie Heller, Professor of Psychology at Carnegie Mellon. Laurie has carried out many research projects related to music and sound perception. Today, Laurie will talk about two of her music-related projects, one involving string instruments, Pluck and bowed, and the other concerning the ventriloquist illusion. I would guess that it could be subtitled, "What You See Might Not Be What You Hear." Please welcome Laurie Heller to the Music and Technology Seminar.
Thank you. Yeah, I have two short talks, so I will take like two questions after the first talk and then move on to the second one. This one was a collaboration with Daniel Rosenberg in the School of Design, which was inspired by a talk he gave in this seminar a couple of years ago. And a bunch of music and technology people helped with this, students. Okay. Next slide. All right. So we studied the ventriloquist illusion in a research project that was inspired by the Wavefield synthesis system in Professor Rosenberg's lab. I'll explain what that is in a minute. But we're just asking, how do we perceive a sound in the context of visual location information? And if the sound and the visual object motion are coherent or incoherent, does that affect the illusion? So the illusion is typically that people tend to hear the sound is coming from what they see that's a plausible source of the sound. So it's called the ventriloquist illusion because when there's a dummy that's sort of moving its mouth and the ventriloquist is sort of not moving their mouth, then you really just feel like the sound is coming from the dummy, even though your auditory localization cues are telling you otherwise. But of course, this applies to a lot of other situations. It also applies to just beeps and flashes that are shown on computer screens. People really do tend to mislocalize sounds when there's a plausible visual event. So we thought this would be the first place to sort of check, hey, how does that work in a Wavefield synthesis environment? It's a really well-known effect, but it tends to be tested with headphones in a lab on a computer screen and on or maybe in a small anechoic chamber or something, but it hasn't been done in this sort of a more open environment with Wavefield synthesis. So that was our first step to find out if that works, and that's pretty much what we'll talk about today. So the Wavefield synthesis system, it's first of all, there's a loudspeaker array that can generate sound in various locations within a region, in a sort of triangular region in front of the Wavefield, the speaker array. And on top of that, there's an infrared tracking system. So if you have an object, like you see these orange mugs with the trackers on them, if you move them around, then the Wavefield synthesis can actually make the sound move with the object that you move. So it kind of makes it feel like that mug is, say, generating the sound. So where we wanted to go with this was to sort of look at motion and how, especially observer motion with the objects, if you move that object around and the sound is moving with it, that really makes you think that the sound's coming from it. But what if you move the object around and the sound's not tracking with it? Then would that break this really powerful ventriloquist illusion? And that was where we were going with it. But first, of course, you have to just get the basic illusion. So Wavefield synthesis, if you look at the picture on the left here, we've got, say, an instrument. This is the only music part of this talk, sorry. A picture of an instrument. But an instrument that's, going to generate a spherical wavefront. It sort of simulates the wavefront that you might be getting with the speaker arrays, sort of recreating the sounds that would be happening farther out from the actual source. And that's as far as we'll get in explaining what that is. But so this is a picture of our initial study. You see we have a little toy dog here, kind of sitting a couple feet away from a listener who's seated in a chair in front of this speaker array. And the speaker array can make it seem as if the sound is coming from the dog. It can really localize it right in that spot. And then you can also make this sound come a little bit to the left or a little bit to the right of the dog. So this is what we did, is we gave like conditions where people were trying to discriminate the locations of the sound. But the dog it was a barking sound to make it seem sort of plausibly like it might come from the dog. Although it's a toy dog, so its mouth doesn't move. No one's really fooled, but it's just got to be enough to semantically sort of suggest that it goes together. And that's an important part of the ventriloquist effect too. So, okay, so we tested some people where we used tracking, making the sounds farther apart or closer together until we reached a 79% correct accuracy, where they would say that the sound was maybe changed from the right to the left or the left to the right. And I'm sort of mimicking that with I think you can see that with my my mouse, hopefully, yeah. Okay, and we did also have conditions where then that dog would actually move and the sound would track with it or without. But first we'll just talk about the no motion conditions. So the task is the listener has this sort of iPad on their lap. They don't even have to really look at it, and they just tap whether the sound moved from left to right or right to left. So they hear two sounds in every interval, in every trial. And so it either went from right to left or left to right. And that's all they have to do. So they can just sort of, without looking down, just sort of tap right or left hand to respond. And then we get their threshold, because we're using the Wavefield synthesis and some code, we can adaptively present the location of the sound. So this is the ventriloquist effect in action here. People had a 6-degree threshold. If you put these two sounds 6 degrees apart, then people were 79% accurate. If there was no dog there at all. And then if we put the dog there, something visual for people to sort of think the sound was coming from, then their threshold was 9 degrees. So this is sort of the first just demonstration of just the basic ventriloquist effect in this kind of an environment. And this allows people, we tell them to keep their heads still, but it still allows a lot more free movement than typical lab studies do. So it's nice that we found that. And then what we wanted to do was compare that to when people were actually moving the dog and hearing the sound move with it. So this is again the setup. It's a little fuzzy, but there's a handle on this little 3D printed tray that the dog is on, and people could move that around during the dog barking. There'd be like repeated barks, and they were given a very stereotyped kind of motion to do with this to the right and the left. And they would move that around, and then they would have the trial. So they're either learning that the sound goes with that dog, or in another condition, with the no object tracking, the sound always stays in the center while the dog moves. So people should be picking this up in these different conditions. But our thresholds are identical, and they're, again, this is like 7.5, so I guess it's better than the 9 degrees we saw in that other one. But no effect of them knowing that the sound tracks with the dog. So that is not what we predicted. And then it leads to like 20 different questions of what could we have done differently, and so on. So we haven't had the chance to do all those things differently yet. But that's the story there. And I want to thank the Acoustical Society of America for funding some summer research on this, and also the Dietrich College seed grant. Okay, thank you. I will take a question on this before I move on to the other talk about bowing and plucking. Anybody have a question?
Laurie, do you have any hypotheses about why there was no difference?
Yeah, about why this didn't work. So many, that's. But so because we wanted to have the trial be the same in all conditions, we didn't allow them to move the sound during the trial, right? So they moved it around, and then they had a trial. And so maybe that was too removed in time. It depends on how sort of cognitive that knowledge is about the sound goes with a dog or not. So yeah, that might have been part of the issue. Another part of the issue, people weren't actually holding the object; they were sort of steering this object. So it's a little less natural than we want. It was sort of a compromise, right, with some experimental control. But so we lost a little bit of that, I think, that feeling that you were moving it around. And so that might be another thing to try. But no, I don't have well, I mean, another possibility is that, people's knowledge about that just really has nothing to do with it. And that the ventriloquist effect is sort of, much lower level than that. Lower level in terms of like it's more perceptual and not cognitive. But there are other studies not in this kind of environment that suggest that cognitive knowledge, really does interact. So I don't know. Sorry.
Thanks.
Other questions? Thanks for your question, Roger. Yeah, I wish I knew. But anything else, or should I move on? Actually, while you're thinking of that, I'm going to play with this because I have to stop the share to move to another slideshow, and that might take me a second. So think about a question.
As far as applications go, is the military or any of those big outfits interested in this technology? Have you been contacted by anyone?
No, they haven't called.
I'm just wondering if
Yeah.
they do a fair amount of stuff with sound, but I just didn't know if there was anything going on with this. They do have a few bucks, so at least they did at one time.
Yeah, I can say something about that. There was probably not a lot. I did work on a classified project once concerning helicopter sounds. And if you're being approached by military helicopters, you can hear them from a ways away. And there was a lot of interest in the part in either disguising the sounds, creating an illusion of incorrect location for where the sounds were coming from.
Yeah,
And
that's what I
various
was
things
thinking,
like that.
something like that.
Yeah.
Laurie,
I'm
is there
not.
any AI activity in this area? It seems like I go on the internet, most people are trying to sell stocks of some new company that's got some contraption, but is there any AI stuff that you're looking at on this area?
Um,
Or do you think it could apply someday or will apply?
AI. Hold on. I'm trying to share this guy. Share. Did that work better? Do you see the?
Yeah, you can see it.
No, you still see the notes though, don't you? That's annoying. Let's try that one. Nope. Nope, nope, nope. Everything shows the notes. That's annoying. Okay. Oh, is that good? Let's see. How are we doing? We're still seeing the presenter view, right?
See the big slide, yeah. Yeah.
Oh, wait. Oh, you weren't seeing the presenter view? I thought it was showing you the presenter view. Okay. Let us go. Was that working? Was that actually working and I quit too soon? Share. Okay. So let's just go like that. How's that? Now it's still showing you presenter view, isn't it?
Yeah.
Yeah, that's annoying. Okay. Yeah, it took me like 10 minutes to get this going before. Let's see. Any better?
No, Laurie, if you put on your display mirror displays rather than extended displays, then that should take care of it.
Okay. Thanks, Rich. It's just not. They
The operative
changed
word is
something.
should, not will.
Yeah, they changed something on Zoom because this used to work. So I don't know. They changed something. It's fine. I'm just trying to get I'm just trying to just do like a regular whatever now, and I'm gonna end the show and I'm going to do just regular presenter mode. No, it's just insisting now on doing presenter mode. So I hate Zoom. Okay. Just do a regular slideshow. All right. I'm gonna do this then. You tell me if this comes out really grainy, but that good? Now you just see the slide, right?
Yeah, that seems good.
It's not grainy or something. Okay, let's give that a try. Yeah, so no, I don't. So to answer your questions, because I was busy thinking about the other stuff, no, I don't know of any military or AI
Okay.
applications for this.
All right, just curious. Thank you.
Yeah. Okay. So let me tell you about something else. And I came up with this theme of neither here nor there because I think in both cases we're dealing with sounds that aren't quite where aren't perceived as quite where they are, and then in the ventriloquist effect, and then here we've got sounds that are not really plucks or bows, and what do people do with that? Okay, and Paige Brady is doing this for her thesis, and this was also a collaboration with Professor Randall for music. So, okay, let's go to the next slide. Okay, so sorry about all the text, but the starting place for this, the history for this project about looking at plucks and bows, comes from the categorical perception of speech. The sounds like ba and ga are really only heard as a ba and a ga, even if you make something that's acoustically sort of in between. People don't hear something acoustically between. They tend to just sort of map it to one or the other really well learned auditory category that they have. And so it was of interest to researchers to try this with other domains to see if speech was really special or whether this could happen with music. And bowing and plucking was a good candidate for that because they're short sounds and they have incompatible actions, right? A bowing and a plucking are just very different actions. So it's hard to imagine sort of an in-between action. So you might expect to get categorical perception there as well. So there was some research on this, and I would say it was decidedly undecided. And so I think those are inconclusive. Personally, I think that it's not categorical for this at all, but we're not really trying to enter that debate. We just were looking at that as there's this continuum that can be synthesized between plucks and bows. And the way it was done in the prior studies was to take sort of like bow sound and then just keep shortening it up until it became a pluck. But when you do studies like that, you don't really know how good that synthesized pluck is at one end. Like you get the maximum ratings and people are like, okay, that's the most plucky sound. You don't actually know that's a good pluck. So we were interested in, well, what would, how would this sort of a continuum, you have to have a continuum of sounds to ask people which category it's in. And so some things that are, 80% pluck, some things that are 50% pluck, and so on. But if your endpoint isn't really a good pluck, then have you really done this? So we wanted to make a better pluck, very by hand, not using AI or anything, just to take one feature at a time and understand it. And that's why it's called deconstructing the pluck. So first we do that, and then we do ask, what makes a sound a good mud point or a good morph? Is there anything special about sounds that make good morphs? Is anything that's just sort of, if it gets a rating of 5 out of 10 on a pluck and 5 out of 10 on a bow, is that the ideal morph? And we'll see, not necessarily. So here's a recording of a bow and a pluck. This is just me in my lab trying to play a really short bow sound, because you got to take sounds that are kind of short, bow short, right? So we've got a bow and then a pluck. And yes, it's really a cello, but you'll see that people didn't always think it was. So we looked at a bunch of different parameters that were temporal. So how the sort of steepness of the sound in the ramp on, that earliest part of the signal. There's a steady state portion in the middle that has a sustained amplitude, and then there's a ramp off. So we sort of manipulated the temporal properties of all of those kind of one at a time. So this is the temporal story, like in a caricature. And this is sort of the way that the original Pluck bow continuums were made. You take a bow that has sort of a gradual ramp on and off. Bowing sounds tend to have that if it's one bow, not moving into another note or something. Then you just sort of slice off that beginning to make it sort of instantaneously rise up to maximum amplitude, and it sounds like a pluck. But in this case, if you do this with the sounds that we have, well, I'll show you the data, but it's not necessarily the best pluck in the world. So, and then another temporal property you can manipulate also is in this decay region, we can have a linear fade or we can have an exponential, and natural systems do have exponential decay. So we expected that to be better. Obviously, Pluck synthesis programs that are out there do that as part of what they're doing. So yeah, there's already perfectly good Pluck synthesis and stuff. We're just trying to do one piece at a time to see perceptually what matters, right? So, and then this one, we also swapped the spectrum. So we took the bow and gave it the temporal properties we wanted, and then we applied the Pluck spectrum to it to see if that made it a better Pluck. Okay, so first we did an experiment in which we just did the Pluck and the bow question, translating a bow sound into a Pluck. And we asked people on a scale of 0 to 10, hey, how likely was this made by a bow? How likely was it made by a Pluck? And then also we asked what kind of instrument they thought the sound was made from. And so our sanity check first, the recordings that we had are rated appropriately. So on the scale up to 10, no one ever gives you a 0 and a 10, right? You get a 1 and a 9. That's about the best you're going to do with a rating scale. So people did think that a bow was a bad Pluck, and a bow was a Pluck was a good Pluck. And then if you flip the scale, the same, the data flips. Don't need to show you that. Okay. So the first thing we did was we looked at the effect of that rise time. Here, if you go up gradually or if you go up abruptly. So 0 millisecond rise time is this really abrupt thing. Oh, over here. That's the 0 millisecond rise time. And then the most gradual rise time is over here. And so you can see that the rating of how good the Pluck is, it does go up, but it only gets to 3. So that's obviously not the whole story. And a really big important factor is how long is that sustain portion. And some of our sustains that we tested were even like 200 milliseconds long. But as we got shorter and shorter, it got better and better. So now we're at like a 5.5 instead of a 3. And this star means that these were significantly different in ratings. So people really did think it was a better Pluck. Then we looked to see whether the ramp off time should be longer or shorter for a Pluck. And a longer ramp off was better, significantly better. So these are higher than those. So now we're up to a 6. And then we also looked at the effect of the fade shape, exponential or linear, and exponential is better. So none of this is shocking. They're all just acoustic features that are pretty obvious. And then once you've got all those things sort of tweaked to the best parameters, does the spectrum matter? This is the 6 that we got with the bow spectrum. And then when we started adding in like a Pluck spectrum to it, we got up to a 7. We were also able to sort of by hand imitate that by just enhancing some low pass regions in the decay region of the sound. So there you go. So spectrum, it's like, it matters a point. That's about as good as we got, was up to a 7. So here's our best bowing sound. And that we had to shorten it up a little bit and kind of ramp it off linearly to make it sort of a similar duration, but it's not terrible. And then this is the best Pluck, which is really the thing that we synthesized. So there you go. And And then we did an experiments 2 and 3, sort of a combined question about, okay, now that we did this, we've got a whole bunch of sounds. There's a lot more sounds than what I showed you, right? We tried all those kinds of parameters, but now that we've figured this out, let's pick some that are kind of in the middle, medium, high pluck and bow ratings, and give them to people and ask them if it's a good morph. And so we gave them a scale of 1 to 5, and we defined morphing to the listeners. We gave them like pictures of visual face morphs to define it, and we played a good bow and a good pluck at the beginning of the trials to remind them what the endpoints are. And we also gave them a definition of what's not a morph. So one sound after the other, a pluck and then a bow, that's not a morph. Or a pluck and a bow played at the same time, not a morph. So we did give them pretty clear instructions. And then I'll just show you, this is the results where we have the pluck rating for some sounds, which should be inverse to the bow rating, right? So if this particular sound, there's a bunch of sounds we tested, if this particular sound was high on the pluck, it should be low on the bow, right? And so that we did find this totally expected sort of slope of -1 here. But what I wanted to pull your attention to now is that the colors are actually how good the morph rating was. And that would be, they weren't asked about pluck or bow, they would just play the sound and said, how good of a morph is this? And between pluck and bow. And our best one is like right here on this picture, these green ones. So you can see that they actually have a relatively high bow rating, kind of 5 to 7, and the pluck rating is relatively lower, 3 to 5 in this range, right? So the answer is no. Something right at 5 and 5 isn't necessarily your best morph. You can have a good morph that's way over here. And I'll play you 2 of the better morph examples that we made, highest rated, but they were only rated, the best rating we got was like 3.75 on a scale of 1 to 5. So nobody was given these like a 5, but here's one, and here's another one. So you're like, well, it's not quite a bow, it's not quite a pluck, right? And so people judge those to be the best of morphs. Sorry, it plays it again when I move on. Probably you'll notice when you hear those morphs that they sound a little bit more electronic. And so this is the real recordings and what people thought the instruments were. So you can hear the bow, and mostly people think it is a cello, that's the purple, but they also think it's a ukulele or a wind instrument. And these are real recordings. And then with a real pluck, they're already not really that convinced that it's a cello. They kind of think it's a guitar or a ukulele. But there's very little electronic answers, right? Thinking that it's generated by a computer. But once you go to the good morphs, we've got a good chunk of people that think it was made by a computer. Still about the same number as plucks that think it's a cello, right? This purple. That's pretty much the story with the data. And then to discuss like why do we do this and what are we taking from this? So there's they talk about the uncanny valley of artificial stimuli. This valley between a pluck and a bow doesn't always make a good morph. Like not every sound that was in that region was a good morph, right? Some were good and some weren't. So there's a certain combination of the features that sort of makes something that people say it doesn't sound like one or the other. So we kind of figured out what were the features for our best pluck, and then we were looking to see, okay, so does our best morph have a combination of which pluck characteristics, so like a short rise time and an exponential fade, but then also having the bow characteristic of a long sustain, because you don't really get such a long sustain with a pluck normally. So that was sort of what you needed to get a good morph. And then I'll end on this question is that the good morphs are more likely to sound like a computer generated sound. And so one question is, does a sound that doesn't have a clear action that made it, like you hear a sound and you're like, I don't know a person's gesture or an object could make this sound. then is it necessarily going to sort of always sound artificial if it's a morph, between two very distinct gestures? So that well, I'll just leave you on that with a question, because I don't think we can answer that with a definite yes with these data, but it's suggestive. So okay, and then let's go to. Okay, now it's decided not to go to the next slide, but that's pretty much it. There we go. Yeah, thank you to the funders. There was a Dietrich Honors Fellowship given to Paige and research assistants who helped with the Wavefield synthesis. So, and that's it. So thank you. Any questions?
Yeah, I'll jump in again. Thanks, Laurie. That was really interesting. And the amazing thing about this talk is I think I read your abstract yesterday, and then last night I was playing with a guitar player that had this effect pedal that removed attacks and made these bowing sounds. And I thought, oh, wow, that's amazing. I think I'm going to learn about this tomorrow. But I got to experience it first. And so one comment I have, kind of based on that experience, is maybe what makes us sound good has a lot to do with context. When I was hearing him play, I was hearing lines and kind of the way notes join together. I think, well, first of all, from earlier research I did, one thing I learned is that the like there, you know, early on there was a lot of study of notes, and people would take isolated notes like a trumpet and then say, okay, this is a characteristic trumpet, like this is what the attack looks like, etc. And then it turns out if you look at actual trumpet playing in phrases, that's some generalizations are just completely wrong, and so context,
Yeah.
really changes things.
And certainly with bowing, right? Because this was just like one little note, which no one is ever really, hardly ever playing a bowing like that. So in music, right?
Yeah,
So
yeah,
yeah.
and I think also in I mean maybe related to what sounds good is I think even if you're bowing a long note, if it's like the end, if there's nothing following it, the contour of the note would probably, I'm guessing, would have a more or less exponential decay
Hmm.
as part of the bow, and maybe
Yep.
probably that's an imitation of what happens to unbowed sounds.
Yeah, exactly that. If you just take the bow and you cut it off at the very end, you do get like a nice instantaneous rise and a reasonable exponential decay, and you get a pluck if you make that sustained portion long enough, and if you look at it on Audacity, for example. Yeah, it's there already. I mean, this is you have to take the bow off the string to get that, but
Yeah.
yeah. So I agree that context is really important. And another thing that what you said made me think of is uh, there's someone who's a fiddler that has decided to make a catalog of different ways that you can bow in sort of these unusual ways, where the bow might like rotate around the strings or something. Like there's on like Appalachian music and stuff. And so there's a whole catalog that someone's developing for different kinds of bowing. And I think some of those bows might wind up sounding kind of halfway to a pluck. For example, there might be a way to physically make something like that. And then they probably wouldn't sound like these.
Yeah, yeah.
Yeah, they sound more natural. So
I,
yeah.
I also thought this idea that some of these morphs that are not, clearly an instrument just sound to us like computers, which obviously is something we've learned from listening to electronic sounds. I think that's a really fascinating observation because there are computer sounds. I mean, we hear a lot of computer sounds that people really like, and it's probably has something to do with them, being novel sounds that you can't imagine where they came from, but they have properties from natural sounds that we like.
Yeah, that's an interesting thought, and we didn't ask people if they liked the sounds or not, um, but that you could certainly ask that. How pleasant is it? Um,
Yeah, although, but you did ask if they were good sounds, right?
we asked if they were good morphs, and we gave them this very
Okay.
clear definition that a morph should sound sort of halfway between a bow and a pluck. So, um, you know, that's still very subjective. Everyone may have a different idea of what that is, but we got some trends. So, but again, we didn't ever get to a morph that was rated between like 4 and 5, which I would consider to be a really good one. So I don't think we quite got there, but these were our, the results from the best ones we found. But
Yeah.
maybe it's not possible to make something that everyone agrees is a good morph between two very different things.
I'm wondering if there are, other types of morphs and cross synthesis where anyone has asked the similar question, and whether, with other techniques, do people ever say, this is really a good morph?
hmm I don't know. I just know that like typically there's a continuum that's been done in psychology research. That's just sort of a continuum that goes from one category to another, like bow to pluck or something, and then people just ask, oh, how bowy is it, or how plucky is it, and then people just sort of read along that continuum and go, okay, I guess this is halfway. And so I do feel like the um, directly asking people what's a good morph instead of trying to infer it from the continuum, I think that's, as far as I know, that's kind of new. I don't know anyone who's really tried to address that. So in theory, you would have the best morphs would be right in that middle, but it's not the case,
Yeah.
at least for these stimuli. So.
Yeah, I don't know if any studies have been done on those, but I'm sure the people who are heavily into samplers and running one tone into another and finding hybrid things that sound really interesting and aesthetic have spent a lot of time trying to do these morphs and make them sound good and sound interesting.
Yeah. Right, and we're not, yeah.
But they probably haven't done a scientific study about any of
Right.
why people think it's good, but I think some people just have a creative knack for that sort of thing,
Right. Yeah, this was sort of the antithesis of the sort of creative process that you're describing, Thomas. Yeah. So, but yeah, that's cool. I mean, that would be a fun job. But yeah, so maybe there's something that artistically seems really good and seems to occupy that space, but maybe you don't get to it by tweaking one characteristic at a time. Maybe you need more of a creative genius to do that. So, any other questions from people, or yeah?
Yeah, I have more. We could talk for a long time. Anyone else?
Roger, I have a question for you. When the guitar had its initial attack erased, did that delay the onset of the beat?
Um, string players always play behind the beat, so it's not. I mean, I think in other contexts, it would, it might have sounded delayed, but in this context of playing like long lines of eighth notes or 16th notes in a solo, it sounded okay.
And what was the point of erasing the attack?
Oh, it was just a different sound. And I talked to the player afterwards, and he said, he said he had this effect. I see Tom wrote envelope follower. Yeah, that's probably what it was. So just like an envelope follower with some lag, so that the sharp attacks would be kind of smeared out.
Yeah, you can adjust the attack and decay on them so that you can make it swell up, kind of like you're using a volume pedal to swell in a guitar sound so that you don't get the sharp attack right off the bat too. So it kind of automates that for you on the Pluck so that you don't have to like keep stepping on the pedal to swell.
Yeah,
But it's definitely something people have used, you know, on and off a lot. And there are some, cool fusion players. Alan Holdsworth is somebody that did a lot of sort of legato type playing that was very violin-like at times. Yeah, it's a cool sound, and putting it in the context is nice.
yeah.
So did you feel like yeah, I'm just asking you, did you feel like his gestures still caused the sounds though? I mean, as you were sitting there playing.
Oh yeah,
Yeah,
yeah.
yeah. Yeah, so
And
it all mapped.
and to get back to Ricardo's question of like why, he told me, for example, he had played with a vocalist and he would accompany the vocalist playing chords and playing guitar sounds, and then there would be like a guitar solo interlude, and he wanted to have, to contrast with the accompaniment, like I'm playing a solo now as opposed to I'm just playing chords behind the vocalist, and so by switching to this effect, it sounded nice, but it sounded really like a different instrument, and it actually did sound very electronic, more so than the electric guitar, without it.
So I see a question on the chat now. It says from Sarah Masters. Hi, Sarah. Wondering if three sounds, the morph bookended by the extreme bow and pluck, would show the complete morph better. Show the complete morph better. Oh, you mean just like in terms of listening to it? Like,
Yeah, when you're
so,
trying to judge whether it's a good morph, if you
Yeah.
had the endpoints.
yeah, we gave that to people in the study, but I didn't play it for you. Yeah, they're fairly separated in time in the presentation. But yeah, we gave them a good pluck and a good morph, recorded ones, and then said, okay, does this? I mean, we didn't play it every single trial, but yeah, they kind of had their memory refreshed, and then on each trial they would get a few individual sounds to rate. So they did have that. It gets very slow and tedious if you make them listen to it every time. So we didn't make them re-listen to Pluck and Bow every
Right.
trial, but yeah.
That's true.
But yeah, certainly in playing the morphs, I could play them with those. Any other questions?
Any other questions or anything in the chat?
I guess, Laurie, back to your ventriloquist thing real quick, not to
Yeah,
derail,
absolutely.
but
yeah, I didn't mean it. Everything.
No. Just because it came to me
Yeah.
kind of as we were going through the other stuff too. Are there plans to look into some of those other things, given that the grant was small and for a certain
Yeah, I mean, we've
thing, but I
definitely we ran out we're just getting our like a last little bit of data like this week and next. If anybody wants to volunteer for the study, please do. But
it seems like there might be a direction on,
Yeah,
something like maybe a
yeah, I mean,
master's
that'd be-
student or someone who would want to take that kind of thing over.
right,
look
yeah,
at it.
I mean, there's definitely a lot to be done, but that particular grant, yeah, that's run out. So, yeah, we could, if someone was interested, we could try to get another grant, but that's where it is. Yeah, we're in the process of trying to write up the results, with a few more conditions than what I showed you, but basically that. Yeah, so thanks. Yeah, if people are interested, I think you have to also negotiate, time in that lab. It's used for other purposes as well. So, But anyway, but it was fun. I mean, it's a neat thing to experience. If you get a chance to experience it, go visit. It's cool to experience like the sound, being there. It's very different from like if you've experienced sound outside of your head in VR. It's very different from that. It's really there. It really feels like it's very compelling. It feels like it's really there in space. I think because you've got like the room reflections and everything that's correct as well. So it's a neat facility, and I'm glad I got to play with it. But
Okay, any other questions? Okay, well, Laurie, thank you so much for doing this again.
sure.
It's always good to hear what you're up to.
Thank you. Thank you for having me. Bye.